Welcome back to Jewelry for Rhino Tutorials. Today I'm going to share the details of how to use Rail Sweep 1 and show you how to design a knitted ring. First, let's learn how to use the tool. I believe this tool will help you to design more easily. Sweep 1. Generated above. Single profile. Select Rail Curve. The number of control points is in Keep mode. Select the profile. Select the object to fit to. We can see that the resulting surface fits on the sphere. Sometimes the width of the surface may not be uniform. This is because there are not enough control points at the corners. So there are several ways to solve this problem. Change the Keep mode to Auto mode. It will increase the number of control points according to the curvature of the curve, and keep the number of control points minimal. This is the first method. Second method. Change to Custom mode. Change the value to 3. This means that there will be 3 more control points between each control point. The more control points there are, the more uniform the surface will be. The disadvantage is that it is difficult to edit the object with more control points. So let me share a third method. Change the mode to Keep. Use the draw on a surface. Edit the curve directly on the surface. Add a control point at the corner. The advantage of hand modification is that it doesn't add a lot of control points. The generated surface can be adjusted with control points. Moving on to other options. Here you can control the position of generation. Select Middle. Adjust the profile and the surface will change. This tool is going to be used a lot in the future, so I'll try to explain it in as much detail as possible. Let's move on to the command prompt. These are 2 curves with high and low levels. Use them to generate 2 effects respectively. Unify direction is no. And then the second one. This time change the unify direction to yes. We can see the direction of the 2 surfaces is different. First surface's direction is uniformly facing the view. No matter how you modify the curves, the result will be the same. As you can see from this ISO curve, the right surface's direction changes with the curve. Look at the ISO curve's direction. Adjust the angle of the curve. The surface turns directly to the side. This is what unify direction does. Let's move on to the other options. Change to multiple profile. It allows you to use multiple profiles in combination. Now, I need to select point 0, and then select the profile to place at point 0. Transition to 2, change to the second profile. And point 3 is also the second profile. When I transition to 6, I change back to the first profile. This will create a transition effect. The ISO curves show how the profiles change in the surface. These 2 positions use the same profile. And the final position are the first profile. That's what the multiple profile does. Let's move on to the last option. Double profile. Select both profiles in turn. It is used to make a transition between 2 profiles. Very easy to understand. The profiles must have the same number of control points. The principle is that the same control points move along the profile, like this. Move the control points in different directions to achieve the gradient effect. Next, I will use this tool to share a ring design case. Now let's make the ring. Switch to front view first. Create a ring size. Right-click to copy in place. Add it to the layer and lock it. Now we have a reference curve. Then trim out the rail curve. Do not exceed 3 mm here. Otherwise, the ring will loosen easily when wearing it. Trim out the opening. Here, whether to trim in half or not depends on your personal habits. I prefer to do it in half and then copy it symmetrically. Remember to rebuild the trimmed curve. 8 points are enough. If you don't rebuild the curve, it will be distorted if you use uniform. Move it 5 mm to the right. Use the taper to make the top wider and the bottom narrower. Project the 0 point to the construction plane. Insert a control point. Flatten the 2 control points. This ensures that the ring shank will be smooth after symmetrical copying. Flatten them in the front view as well. Then adjust the curves according to the reference curve. Adjust the curvature of the corner to make it look fuller. The middle part can be bulged out a little bit, so that it doesn't look concave. Looks good. Draw a profile of the ring. The inner face of the ring can be a little flat. On the outside, it should be a little more bulbous. Copy it. I'm going to use double profile of sweep 1. Use the JFR edit box to modify the profile size. 2 mm thick. 1.7 mm wide. The profile below represents the bottom half of the ring. It can be made thinner, 1.5 mm. If we want to create a surface with sweep 1, we need a fitting surface. Right-click on the layer and select Object. Extrude the surface. Open the rail. Select Double Profile for type. Select Rail. The 0 point of the curve is at the bottom, so choose a thin profile for the first one. Select the second one. Fit the surface. Open control point serial number. The 0 point is at the bottom, so the profile below is correct. Vertical mirror first to adjust the base shape. There are fewer control points, so there is a bit of distortion at the corners. Open the control points and adjust it. Then the width will be uniform. Tweak it a bit here too. The advantage of a single surface is that it can be adjusted at will. The transition in the center should be smooth. We're done with the outer frame. Now we're going to do the knitted ribbon in the center. I'll need a surface to create the knit pattern. Hold down Alt and copy a curve. Change the color to a more vibrant color. Remove the extra points. Vertical mirror. The tool I just used was Isolate Objects. You can find it in the visibility bar. This tool is very useful, so I've set up a shortcut for it. To show curves individually, press E. Press twice E to show back all objects. If you haven't used this tool before, I highly recommend it. Find the Loft tool. Generate a surface from curves. Vertical mirror it. Delete the center control point. Use the JFR Loft Surface tool to join the two surfaces. Flip it. Show the reference curve back. Smooth the surface according to the reference curve. The more evenly spaced the surface control points are, the better. This way, the knit pattern will be more evenly distributed. Launch Grasshopper. In the Pattern tool, take out the knit pattern component. This tool generates the knit pattern automatically. Here you can modify the density and size of the pattern. Make it narrower. Enhance the heights. Take out the group baking component. Check the size of the pattern before baking. Adjust it a little bit. Click on the icon to generate. Copy a profile. Use Edit Box to modify the size of the knitted ribbon. 1.2 wide, make it narrower. Thickness 0.9 is enough. Select Curve, then open the Rail tool. Change the position to the middle. Single profile. Change the color first. Select the last object created. We can change the size of the surface by adjusting the curve. In the front view, use Scale 2D to expand it outwards. I'll try to click on the icons to make it easier to learn. Enter 0 to set the center of scaling. Expand the pattern curve outward. This is the way to change the surface by modifying the curve. Now I'm going to show you a more practical way. Delete them first. Find Sweep 1 in the Surface category. Connect the curves to the Sweep 1 component. You can also export it from the front. Fitting surface. In Grasshopper, you can preview and make adjustments in real time. It's easier to modify. Take out the curve grabbing component here. Grab the profile. This method is very convenient for us to modify the design later, thus saving a lot of time. Adjust the height. Press the middle mouse button to hide the pattern curve. That's it, very simple. Adjusting the knit height difference. Lower the height a little bit here so that it fits better on the inside of the ring. Once the shape is finalized, it's time to bake it. In addition to baking the component in a group, you can also right-click here and bake it. Select the group. Change the color. The whole ring is now complete. Now let's move on to the gem setting step. I need a curve to generate gems. Extract isocurve. Using gem on curve. Fit the surface. Switching display mode. The gumball is on the other side, so it's best to invert the curve first. Adjusting gem spacing. Normal spacing is between 0.1 and 0.2. Slightly lower. Gemstone size needs to be bigger. Lower it a bit more. Gemstones should be in the center of the first and last points. Press space to generate. Next, start the microsetting. These steps are all visualized. It's just easy to get started. But JFR has other methods that work better and are more efficient. I'll be making more tutorials to teach you other ways to do microsetting in JFR. Right now, it's still in the beginner's stage of learning. The center needs to be arched. Deepen the thickness. The depth of the U-groove is about the middle of the gemstone's girdle and the tip of the stone. Switch to V-groove. Raise the center. That's it. Check the other views for any adjustments. This position needs to be adjusted separately. Toggle editing mode to single mode. If it's okay, press space to confirm. Take these objects out of the group and rotate them. Use the JFR roll tool to roll the objects in place. This is also a very handy tool. Move it a little bit. The inside of the U-groove needs to be narrowed a little bit. This one is not on the center axis, so you have to scale it with the JFR scale tool. Left-click on the icon and right-click to drag. And that's it. Next, make the middle groove as well. Extract ISO curves. Need 2 curves. Use double curve to microprong setting. Switch to ghosted display. Each part to be adjusted can be found here. Increase thickness. Normally, it should be as deep as the other groove. So how do I determine the width of this groove? Usually, the stone should be embedded about 0.1 mm. Make both sides symmetrical. Well, that's pretty much it. Boolean out all the grooves. Delete the extra ones first. All the objects don't need cap. Use JFR Boolean difference to Boolean them directly. Here's something else that was missed. Boolean these two. Finally, we still need to do the holes for the gems. Use gem cutter. There are 2 patterns for the bottom of this hole. Here, I changed it to a round one. As for the girdle of the gem, it depends on your needs. If you are going to use it for rendering, it is recommended that it is slightly larger or equal to the size of the gemstone, so as not to affect the refraction of light inside the gemstone. If you're going to use it for 3D printing, casting, I recommend that this hole be smaller than the stone, or else the metal here won't be able to hold the stone well. So the hole of the stone should be smaller than the gemstone. This is the shape that we usually use. Generated. And finally, Boolean difference. Look at the result. And that's it. Change the color of the ring shank. 4-quadrant mirror. Take the center gem out of the group. Then revolve 180 degrees. The ring design is now complete. If you're a jewelry designer, I'm sure these tools in the video can make designing easier for you, so that you can accomplish more complex designs. That's all for this video. If you enjoyed this video, please like, share this video and subscribe to us. See you next time.